Laws of illumination. Law 1. Statement: illumination is directly proportional to the luminous intensity of the surface. This means that if you increase the brightness or power of the light source, the illumination on the surface also increases proportionally. Imagine turning up the brightness on a flashlight. As it gets brighter, the area it illuminates becomes more intensely lit. Law 2. Inverse squared law. Statement: the illumination on a surface will fall off the inverse square of the distance from the light source. This law states that as you move further away from a light source, the illumination decreases rapidly. Specifically, if you double the distance from the light source, the illumination becomes one-fourth. Think of how a spotlight shines brightly on the stage but quickly becomes dimmer as you move away from it. The inverse square law states that the illumination falling on a horizontal plane varies inversely with the square of the distance of that surface from the light source. The formula is such that illumination at A is equal to I on H squared, where I is the luminous intensity in candles, H is the distance from the light source to a point A in meters. This formula tells us that the illumination, light falling on a surface, is equal to the intensity of the light source divided by the square of the distance from the light. I was just saying that this formula tells us that the illumination, which is light falling on a surface, is equal to the intensity of the light source divided by the square of the distance from the source to the surface. If you have a light source with a certain brightness, the further you move away from it, the more the illumination decreases, and it decreases faster because it is squared. Assumption here is that point A is directly below the light source. The calculation is simplified by assuming the point being measured is directly below the light source, making the distance a straight line. Firstly, a light source is positioned above point A. The distance between the light source and point A is denoted as h. This figure helps visualize the inverse square law. The light source above A creates a cone of light. The distance h is the height of this cone, and the illumination is the strongest at point A below the light source.